Hey kiddos, today we're going to be starting our new unit on geometry basics. So let's get to it. All right, so this is a lot of vocabulary. It's very vocab heavy. So I'm just going to kind of go through this and hopefully you're following along. Point. It has no dimension. Okay, that's what represents a point. It's named using an uppercase letter. Remember, points don't have size, they have a specific location. Line has one dimension. It's represented by a line with two arrowheads. Okay, so two arrows at the ends. Through any 2 points, there's exactly always one line. Named using any 2 points on a line. Okay, for example, here the A and the B, or a lowercase script letter. So notice here like this lowercase cursive L. A plane has two dimensions, okay, represented by a shape that looks like a parallelogram, extends without end. Through any 3 points not on the same line, there's exactly one plane, okay, coplanar. Named using any 3 points that are on that plane, not on the same line, or a capital script letter, capital letter, okay? Collinear points are points that lie on the same line, okay, usually 2 or more. Coplanar points are points that lie on the same plane, also usually 2 or more. A segment, okay, line segment AB or segment AB, and notice this is how we would write it, line over top with AB on it. Notice this is a segment symbol because it doesn't have arrows at the ends. It consists of endpoints, A and B, and all points that are in between A and B. Okay? Notice direction does play a role here, so we can actually call this segment AB, or we could call it segment BA. So order does matter. Ray. Okay, not sunshine ray, but a ray here, written as AB. Notice it has a line overhead that has only one arrow, okay, because it consists of an endpoint and then all the points in between on AB that lie on the same side as A and B. So we get one endpoint. It consists of all of these points in between, okay, that extend all the way through that arrow. Notice there is a difference between AB, ray AB, and ray BA. I told you direction matters, so order does matter. AB, you notice, is going forever to the right, and that BA is going forever to the left. Okay? Opposite rays, okay, are basically when you have two rays, okay, two rays, so I have ray CB, then I have ray CA, that basically share a common point, okay? So that's what it means when we say opposite rays. Essentially, opposite rays create lines. Intersection. Okay, we have a few different types of intersection that can occur. Two or more geometric figures intersect when they have one or more points in common. So the most traditional intersection that you guys have seen, like in algebra, is when you have two lines that intersect. Okay, so that's that first example. So the intersection of two lines is always going to be one point. So in this case, point I there. The intersection of a line and a plane. So in this second situation, we have a plane and we have a line J here and plane M. So when they intersect, notice they also intersect at exactly only one point. So that's point P. And then the more unique intersection that we'll come across is when we actually have two planes intersect. So when two planes actually intersect each other, they don't intersect at a point. They actually intersect at a line, or in this case, a line segment. Okay? All right, so if you have a ruler, please use one or really try to draw as straight as possible. Please don't make me have you redo this because you're being sloppy. A point. Okay, drawing a point. You don't really need a ruler for that. Literally, you draw a point, and then you label it with a letter P because that's what I said specifically. All right, next one, a line, LM. Okay, notice a line. So I should have arrows at the ends. As such, make sure you got arrows at the ends. And notice I asked you to label it with the letters L and M. Next one, array. So array only has one arrow and one endpoint. Pay attention to the letters here. S is where the endpoint should be. R is where the arrow should be. And another array, notice this time I'm switching it up. R should be where the endpoint is, and S is where the arrow is. Looks like that. Make sure that if you want to attempt to draw these before you see the actual answer to make sure that you got it, feel free to do that, okay? So E, line segment JK. Line segment means we should have endpoints at both ends. So it should look like this. F, line A and line B intersect at point C. So notice I'm going to have two lines that are going to intersect at a specific point C. All right, so notice here's line A, here is line B, and they intersect at point C. Now to draw a plane. Plane PQR. So because I gave you three letters to name this plane, they would be identified as 3 points on the plane. H. Line EF and line GH are parallel. Now hopefully we recall parallel lines have the same slope, and most importantly, they never, ever, 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 ever touch. So line EF, arrows at the ends, line GH, arrows at the ends. They are never going to touch. Notice this symbol right here that you see is the symbol to show and demonstrate that these two lines are in fact parallel. I, opposite rays. Okay, opposite rays, YX and YZ. So automatically you should be able to tell which letter is going to be in the middle here. They're both going to have the Y in common. So we have YX and you have YZ. Two opposite rays that essentially end up creating a line. All right, naming points, lines, and planes from a figure. So notice you have a figure here, okay? And I'm going to ask you a few little questions, and all I need you to do is name the point, line, and planes. So give two other names for line PQ. Line PQ. Line PQ. What other names can we give to line PQ? We can call it line N, okay? Notice there's that small N right there that denotes that. And another answer would be line QP. Just switch the direction. All right, B. Give two other names for plane R. So notice this is plane R. All right, see that R is right there, labeling it. Another name could be plane SVP. Notice I picked 3 different points, SVP. Notice all 3 of those points are not on the same line. Okay, so I can justify that. And plane TVS. Same situation. Make sure that the points that you picked are not all on the same line. So if you would have said SPT, that would have been no bueno. Those are collinear points. Not a good name for a plane. That kind of rhymes. Oh, please don't think I'm lame. Now let's name 3 points that are collinear. Yeah, that was kind of good. All right, so 3 points that are collinear, coincidentally, SPT. Now D, name 4 points that are coplanar. Okay, remember coplanar, got to be on the plane. Okay, so name 4 points that are coplanar. S, B, P, T. Those 4 points are coplanar. All right, now we're going to look at naming segments, rays, and opposite rays from this figure. Okay, again, guys, if you want to see if you can answer these before I actually show the answer, pause and try it and then see. So, A, give another name for GH. So give another name for line segment GH. Another name could be switch direction HG, line segment HG. B, name all rays with the endpoint J. So we want to name all the rays that have the endpoint of J. Might be a few here. So we have ray JE, ray JG, ray JF, and I think there's one more, ray JH. Now, name two pairs of opposite rays. Okay, remember opposite rays basically create a line. So that's kind of hint what you're looking for. You get pair GH. So GH, I don't even know how to say my letters. JG and JH create one pair of opposite rays. And the other pair would be JE and ray JF also create opposite pairs. All right, some more sketching, putting your art skills to the test here. So we're going to be sketching intersections of lines and planes. So sketch a plane and a line that is in the plane. So your masterpiece should look something like this. Notice I have a plane and a line, AB, with arrows at the ends that is inside of my plane. Notice I also gave my plane a name. Sketch a plane and a line that does not intersect the plane this time. Okay, so notice key here, not intersect. Your masterpiece should look like something like this. Okay, I have my plane M and my line AB. Sketch a plane and a line that intersects the plane at a point. Okay, always use reference your notes or earlier pages that we did. Okay, your masterpiece should look something like this. Notice I have a plane. This time I chose to call it plane N. And my line is still AB, but point B is where the intersection occurs between the plane and the line. D, sketch two planes that intersect in a line. So this is going to be a little bit more trickier to draw, I know, but your masterpiece should hopefully resemble something that looks like this. Okay, so I have plane R and plane S, and they intersect at line AB. Example 5, intersections of lines and planes. Notice we're going to be using this figure here. So A, name the intersection of line PQ and line K. So where those two lines intersect, we get M, point M. B, name the intersection of plane A and plane B. So find them first. Here's plane A, plane B, and the intersection is line K. Notice it is this line right here, line K. Name a pair of opposite rays. Opposite rays. I've decided to pick MP, ray MP, and ray MQ. Opposite rays, and coincidentally, they do create a line together. D, name the intersection of plane B and line PQ. That would be point M. Example 6, modeling with math. The diagram shows a molecule of a sulfur hexafluoride, the most potent greenhouse gas in the world. And this is what it looks like. Be scared. Name two different planes that contain line R. First, you need to find line R. Line R. Name two planes that contain line R. The two planes are A, B, F, A, B, F, and G, B, F. B. Name 3 different planes that contain point B. Point B, this point here. So name 3 different planes that contain that point. We have plane ABD, ABD, so this plane here. We have DEG, DEG, TEG, this plane here. And ABE. ABE. ABE, this plane here. Notice you could have also said FBE as another plane. Okay, so you had a few different options. C, name 2 different planes that contain PC. Line PC. Where is line PC is the first thing you need to ask yourself. There's line PC. And what are 2 different planes that contain this line? One option is FBC, plane FBC, FBC, that contains the line, and GBC, GBC, that also contains the line PC. Example 7. Name 2 different planes that contain line QP. Line QP. We get plane NPQ, NPQ, so NPQ, so this plane here, and RSP, RSP, so it's this bottom plane here. Remember, this is 3-dimensional, so you do have to kind of keep that in mind. If you need to, I've always told my students that sometimes it's helpful to break apart the pieces. So for example, this would be the bottom piece, that's Q, R, excuse my horrible handwriting, P, and then I can do the right side, that's P, that's S, that's L, that's M. It just kind of makes it easier to really be able to tell where do those points and lines connect on these different planes. Okay. B. Name 3 lines that intersect at point K. So first thing you need to figure out is where point K is. So what 3 lines, or name 3 lines that intersect at this very point? We get line NK. NK, good one. All right, we also have RK. RK, it's another good one. And we also have LK. LK. Next one. Name 2 planes that will never intersect. What are 2 planes that will never, ever, ever, ever touch? Basically, what are 2 planes that are essentially parallel? Because if they're parallel, they're never going to touch each other. Okay? So 2 lines that will never intersect are RKN, RKN, which is this plane here, RKN, will never intersect with MLS. MLS. Notice they are, in fact, parallel to each other. Name 2 planes that intersect at line KR. Line KR. So find that line first. Line KR. And what are 2 planes that intersect there? So what are 2 planes that share that line? We get NKR. So plane NKR, which is this plane here. I don't know if I can, maybe this would be NKR. So this plane here. And plane LKR, which is that whole back piece. Those 2 planes intersect at this line. Okay? All right, and next one, name two lines that will never intersect. So instead of looking at planes that'll never intersect, what are two lines that'll never intersect? So basically, what are two lines that are parallel? You have a lot of options to pick from. A ton of lines here are parallel to each other. And I have KL, KL, and M. One little thing I do want to add to here is the concept of skew lines. Skew lines. So skew lines are basically two lines that are not parallel, okay, not parallel, and also will never intersect. So you're probably wondering, how can you be not parallel and not intersect? Well, because we have three-dimensional figures, it is quite actually possible. So notice here, I've highlighted line QP and line LS here. LS is on the backside of this prism that we have here, okay? So that will never ever interfere or intersect, I should say, this line QP that is actually in the front part of our prism, okay? Those lines will never intersect and they're not parallel, and that's what we consider skew. All right, line postulate is basically something that states that through any 2 points, there is exactly one line. Pretty basic, okay? Number 2 here, line intersect postulate states that if two lines intersect, then they intersect in exactly 1 point. Notice we've already talked about this. I'm just giving you guys kind of a name because these are actual postulates, okay? 2 more here, plane postulate and plane intersect postulate. Plane postulate states through any 3 non-collinear points, there's exactly one plane. Plane intersect postulate states that if two planes intersect, then their intersection is a line. Okay, make sure you know that. All right, now let's talk about segment addition postulate. So kind of getting into a little bit more math-like type stuff with numbers involved. If X is a point on line AB, so I have line AB here and I have point X, and yes, you have to draw this. Thank you. And X is in between A and B. Then AX plus XB would equal AB. So, example here, if I have AX is 5, 5 plus XB is 3, and I just simply add those together, yes, I know, very basic, we'd get 8. So that would mean that line AB is 8. So let's do a few more segment addition examples. So number 1 here, points A, B, and C are collinear, okay, meaning they're on the same line. Point B is in between A and C. Find the length indicated. So find AC, that's what we're looking for, so it's the whole thing, if AB is 16 and BC is 12. So hopefully you recognize that all we really have to do is say 16 plus 12, and we get 28. So the entire distance from A to C is going to be 28 units. All right, here's another one. We're looking to find the length of KL. KL is this little piece right here. Okay, notice a little question mark. All right, now they tell us that the whole thing is 26. So we know the whole thing's 26. All right, whole thing's 26. And they also give us IJ, which is 9, and JK, which is 11. So what do you think we should do with those two pieces? Hopefully, I'm hearing you right, and you're saying add them. Yes, we should add them. So 9 plus 11 gives us 20. All right, now, if we know that from I to K is 20, and that the whole thing is 26, how could we figure out what KL is? Hopefully you're saying subtract. So we would just subtract what we know, I to K to B, which is 20, from the whole thing, which is 26. And what we're left with is 6. So the length of KL is going to be 6. All right, now we're going to go a little bit more in depth. Those are kind of basic with just plain numbers. I know, adding and subtracting. Okay, now find the length of DE. DE is right here from D to E. So this is what we're looking for, DE. If we know that the whole thing is 33, and we know that DE is 3x minus 28, EF is 3x minus 30, and FG is x, how are we going to algebraically be able to figure out what DE is? Well, hopefully you're noticing that we're going to have to create an equation and that we're going to have to solve for x and then substitute x back into 3x minus 28 to figure out what DE is actually. And I didn't really mean to rhyme right then, but that worked. Okay, awesome. So hopefully you guys got segment addition in your brain because that's what we're going to be doing. We're going to add DE plus EF plus FG. And we're going to make them equal to 33 because that's what the entire distance is. So 3x minus 28 plus 3x minus 30 plus x all equals 33. All right, very basic here. We are going to have to combine like terms first. So I'm going to underline all my x variables. I'm going to put little squiggly lines underneath just my numbers. And let's combine. My x's, I end up with 3x plus 3x is 6x plus another x gives me 7x. And then negative 28 plus a negative 30 is actually going to lead to a negative 58. And that'll equal 33. Solving for x. Draw a box around my variable. Got to do the opposite to cancel out 58. So I'm going to add 58. 7x, that cancels, equals 58 plus 33 gives us 91. Oh, I hope this is going to work out perfect. Last step is going to be to divide by 7. X equals 13. Now, please do not tell me that is your answer because it's wrong. Because they asked for the value of DE. So we have to plug it in. So DE was 3x minus 28. Okay, so what we're changing x for is 13. So 3 times 13, okay, gives you 39 minus 28. And 39 take away 28 leaves you with 11. So the length of D to E is equal to 11. Yay! Last one, and this one I actually want you to try on your own. You knew it was coming, I know. So, points A, B, C, D, and E are collinear and in that particular order. Remember, I did tell you, order doesn't matter. So there's my big old line. We got A, B, C, D, and E, all in that order. Find AC. Find AC if AE, make sure you're paying attention, A to E is x plus 50, and C to E is x plus 32. I think you guys can handle this on your own. And if you have any questions, be sure to jot them down and we'll discuss in class. Ciao!